Hello and good morning. My name is Elima Bilas, and it's a pleasure for me to be giving a presentation to you focusing on environmental protection requirements. I am managing the Environment and Sustainability section in the Certification Directorate of EASA, and I'm working with EASA's environmental experts. These experts work on one of the core tasks of the agency, ensuring environmental compatibility of aviation products in Europe. This presentation aims at firstly introducing the main requirements in the domain of environmental protection as applied to product certification by the agency. Secondly, highlighting the new environmental standards applicable and giving a short summary of the first experience gained through the first noise certification of an all-electric general aviation aeroplane. Thirdly, I'll be introducing the current environmental protection requirements, development activities for novel technology areas such as supersonics and drones and urban air mobility concepts. And lastly, I'll be explaining new tasks of the agency in the area of the Balanced Approach Regulation 598/2014. Without further ado, let's dive into the first section of my presentation. Environmental requirements for product certification are globally harmonized at ICAO and are directly applicable in Europe by reference to ICAO Annex 16 through Article 9 of the Basic Regulation, Part 21 specifying the applicable environmental protection requirements, and Paragraph 21B85, and lastly, EASA certification specifications for engine emissions in CS34, aircraft noise in CS36, and airplane CO2 emissions in CS CO2. The standards for environmental protection requirements are defined in the respective ICAO Annex 16 volumes. The applicability to the relevant product categories is defined in the respective ICAO volumes at the aircraft level and the left and center icon for noise requirements and airplane CO2, Volume 1 and Volume 3 respectively, and engine level displayed on the right-hand side for engine emissions requirements, which are laid down in Volume 2 of ICAO Annex 16. EASA disseminates environmental certification data through its website. The all-new EASA Aeroplane CO2 emissions database is containing the first ever CO2 certified aircraft, the A330neo. Next, the EASA noise database contains all certification noise levels for aircraft configurations certified by the agency. And by the way, this data is transmitted to the national aviation authorities and serves as the basis for the issuance of EASA Form 45 noise certificates. Lastly, ICAO Engine Emissions Database is one of the databases hosted by EASA, and it contains engine emissions certification data. So we'll now move into the second part of my presentation, in which I will focus on the newest environmental certification requirements that have come into force, starting with aircraft CO2 requirements, followed by non-volatile particulate engine emissions requirements, and furthermore, I will give a brief update on the takeaways of the first noise certification of an all-electric aeroplane. With that, I will move to the new aircraft CO2 standard. The CO2 standard is applicable for new types of large transport aircraft as from January 2020. There is a transitionary phase between 2020 and 2028 in which changes resulting in CO2 changes and other than large transport aircraft are gradually subject to CO2 certification requirements. What tells us the CO2 metric? Well, in a nutshell, it is the reciprocal of the specific air range SAR in kilograms fuel per kilometer flown, averaged for 3 reference points and adjusted for fuselage size. 3 reference points for different weights are taken into account for low, medium, and high weight and in their respective optimal conditions. EASA is involved in the relating CO2 compliance demonstration by means of dedicated flight testing and assessment of performance data. What is the applicability of the CO2 standard in detail? The following aeroplanes are affected: new aeroplanes, subsonic jets above 5.7 tons of maximum takeoff mass, propeller-driven aircraft above 8.6 tons of takeoff mass are affected from January 2020, and new business jets will become applicable as from January 2023. Then, furthermore, derived versions of non-CO2 certified aeroplanes will become applicable as from 1st January 2023, with derived meaning an increase of CO2 of more than 1.5% or a significant CO2 change. And finally, in-production aeroplanes will be subject to the new requirements as of 1st January 2028. Let's now turn to requirements for non-volatile particulate matter emissions. This requirement is a standard applicable at engine level in comparison to the CO2 standard, which is applicable at aircraft level, and replaces the outdated smoke number standard. The newest requirement for compliance with NVPM standard, that is the non-volatile particulate matter standard, will affect all engines in production after 31st of December 2022. All engine manufacturers with products that requirement is applicable to need to demonstrate the compliance with the NVPM Cape 11 landing and takeoff standard. The engine type certificate data sheet issued by EASA will then be amended to capture the respective compliance. Last but not least, in this presentation block, I will now turn to the lessons learned from the noise certification of the first all-electric general aviation aeroplane. EASA certified the fully electric Velis Electro SW128 of the manufacturer Pipistrel about a year ago against ICAO Chapter 10 4B noise requirements. Results and lessons learned were presented to ICAO Cape Working Group 1, which develops and maintains noise certification standards. The main conclusions so far: the prop noise is still of high relevance. Helical tip mark number corrections need to take into account the slightly reducing RPM over the duration of the test. Overall, for now, it can be said that Chapter 10 seems to be fit for purpose for all electric aeroplanes. We have currently no indication that new regulatory schemes would have to be developed to specifically accommodate the noise certification of all electric general aviation aeroplanes. Let's now turn to the third part of my presentation, in which I want to address how we cope with the novel technologies. Firstly, let me emphasize that EASA works with its international partners to ultimately define globally harmonized environmental protection standards. Only in order to bridge the gap until those globally harmonized requirements have been enshrined in the respective Cape Annex 16 volumes, the basic regulation now foresees the mandate to establish dedicated European environmental protection requirements. While working on those environmental protection standards, we are guided by our strategic objectives, namely, environmental certification is innovative and cost-effective, facilitating new technologies that are environmentally compatible, and environmental standards are smart, proportionate, and contribute to the competitiveness of the industry. Let's now look into specific examples of novel technology and how EASA engages in defining environmental protection requirements for those products. A new field of technology which is worked on by many companies and is the next generation of supersonic transport aeroplanes, the heirs of Concorde. While this fascinating technology opens up new opportunities, it also comes with a number of considerable environmental challenges. To address these challenges, and to give guidance to the manufacturers, EASA is working in 2 regulatory streams to first prevent sonic boom in Europe by banning flights at speeds at or above Mach 1 over Europe through amending the single European rules of the air. At the same time, the agency experts are engaging with international standard-setting bodies in the development of a potential en route noise certification scheme that could ultimately enable low-boom overland flights. And secondly, while the first stream looks at more operational aspects, the second work stream targets the definition of environmental protection requirements for supersonics in the area of defining landing and takeoff noise standards and aircraft CO2 emissions requirements. These certification requirements could be published for consultation as early as in the beginning of next year. Drones and urban air mobility concept, or air taxis, are another fast-growing sector that offers new business opportunities, but similar to supersonics, comes with challenges in the domain of environmental protection. EASA has been commissioning a number of studies to investigate source noise characteristics of drones and eVTOLs, as well as starting to investigate psychoacoustic studies with the aim of building those response relationships for drones and urban air mobility concepts, noise versus annoyance. These activities, which are currently underway, are initiated to aid the design of an appropriate noise measurement scheme that accommodates a wide variety of drone designs. And you can see on the left-hand corner a number of examples for different drone designs. While working on this scheme, the challenge is to cover multiple designs and parameters, design a comprehensive and robust measurement procedure, define the noise metric, and ultimately set appropriate noise limits that on one hand facilitate the novel technology, while safeguarding, on the other hand, the maximum permitted noise levels are not harmful to human health. Amidst this endeavor, the noise measurement scheme will have to satisfy a number of key criteria. The noise measurement conducted following the scheme will have to be repeatable, accurate, fair, meaning ensuring a level playing field, proportionate, and representative of noise impact to population. Similar to supersonics, we will be working on defining applicable environmental requirements, which will ultimately be published for consultation. Let me now come to the last part of my presentation, the implementation of the so-called Balanced Approach Regulation. The actual full title of the Regulation 598/2014 is Establishment of Rules and Procedures with regard to the introduction of noise-related operating restrictions at Union airports within a balanced approach. This regulation puts specific obligations to EASA I want to briefly introduce to you. Firstly, the agency is requested to collect, verify, and make available aircraft noise and performance data. This is data that is used for computation of noise contours around airports, and this task has previously been carried out by Eurocontrol. We frequently publish new aircraft noise and performance data sets, and these are available on the agency's website. Secondly, the agency is collecting noise documentation of individual aircraft operating in and out of Europe. Through a dedicated environmental portal, also referred to as Aircraft Noise Certificate Database, ANC, we make this data available. As said in the beginning, access to both data sources can be found on the EASA webpage. This closes my presentation, and I hope you found it useful. I thank you for your valuable time and attention. Thank you.